work some of the homework problems. So let's just jump right in. This is actually number 9. And they give us a picture. And they want us to find the area of the shaded region. So I'm just going to sketch this. This is a standard normal distribution. And they have a z-value of 0.49. And they want us to find the area to the left of that particular z-value. Now let's just recall that the total area underneath this curve is 1. The mean of this distribution is 0, and the mean is in the middle. And z stands for the number of standard deviations from the mean. So a standard deviation of 0.49, or a z of 0.49 means 0.49 standard deviations to the right of the mean. So we want to find out how much area is enclosed to the left of there. So we have a table for that. They give us 2 different tables. If we click on the first table, this first table is for negative z values. And notice the the answer is giving us is the answer of the area to the left of that particular z value. That is also known as the cumulative area. If we start adding up area from the left until we get to our particular number, these are the areas that we'll have. The second page has positive z values. So notice on the left side we have numbers to the 10th place. Our z value is 0.49. So we find 0.4 in the first column, and then we follow that row over till we get to the 0.09 column. So 0.49 is this value. Notice also for reference they give us the 0.4 over here. So 0.49, those come together at 0.6879. So 0.6879 is the area of that particular region. That is also the probability of z being less than 0.49. The total area is 1, so that corresponds to 100%. 100% of the data is underneath the whole curve. So if we want to find what portion of our data is less than 0.49, it's that area. So 68.79% of the data is to the left, or we could say that the probability of randomly selecting a piece of data that has a z-value less than 0.49 is 68.79%. All right, so that's one. Let's take a look at some others. Let's take a look at this one, number 10. They give us a standard curve with a z-value of 1.79, and they want us to find the area here. So let's just, if this will let us, let's copy this over. So remember what we just got through saying. The area underneath the entire curve is 1. So from here to here, that entire area adds up to 1. If we look up a z-value of 1.79 in the table, it's going to give us this area in here. So let's do that. If we go to our chart and look up a z-value of 1.79, here's 1.7. And this is the 0.09 column, so 1.79 has an area of 0.9633 to the left. 0.9633. So for right now, I'm just going to call this over here B. So if we take 0.9633 and we add this area, B, that total area has to be 1. So in other words, B is the complement. It's 1 minus 0.9633. So this area is the complement of that one. It's everything else. So 1 minus this area will give us this. So what's that, 0.0367 for that area. So let's continue on. So we've done basically a left-handed region and a right-handed region. Now let's look at finding the area between two z-values. Let's look at finding the area between a z-value of negative 1.6 and a positive 1.4. So if we copy this over, all right, so we want to find this area. If we look up a 1.4 in our table, if we look up this particular z-value, then we're going to get the area from here, not just to here, but all the way to there. So we're going to get all of this and all of this. So let's just do that. If we look up a z of 1.4, so here's 1.4, and we don't have another z digit. So 0.9192 is the area to the left of there, 0.9192. If we look up a z-value of negative 1.6, that's going to give us the area to the left of there. So let's do that. So we'll have to go to the other table that has negative values. So we're looking at negative 1.6. So here's negative 1.6. Negative 1. This one is a little tricky because it's counted down. So here's a 0 in the hundredths place. So negative 1.60 would be here, 0.0548. 0.0548 is this portion. So if we take that whole area, so I'll just highlight. So all of that area is the 0.9192. And we take away the part that we don't want to include. We don't want to include that area, which is 0.0548. So take away that part. How do you take away? Well, you subtract. And when you subtract those, that'll give you the area in the middle. 0.9192 minus 0.0548. So the area in between those is 0.8644. 0.8644. So that gives us the area between those two particular z-values. That's equivalent to saying, what is the probability that our given z-value is less than 1.4 and greater than negative 1.6. All right. All right, let's take a look at another one. This one is number 16. It says, find the area between z equals 0 and z equals 0.38. So z equals 0 and z equals 0.38. So we want to find the area in between there. So let's begin by sketching that region. So if we draw a normal distribution, a z value of 0 is in the middle, a z value of 0.38, that's a positive number, so that's to the right. So we're looking for this area. So if we look up a z-value of 0.38, so we go to our table and look up 0.38, here's 0.3, here's 0.8. So our area to the left of 0.38 is 0.6480. From here over 0.6480, that is all of this. But again, that includes stuff that we don't want. We do not want to include this part. Notice that this bell curve is symmetric, and the line of symmetry is in the middle. Half of the area is to the left, half of the area is to the right. So the area to the left of the middle, that whole area is 0.5. That's what we were wanting to get rid of. If all of this area is 0.648, we need to get rid of this area, which that area, everything to the left of the middle, is 0.5. So subtract 0.5, and that leaves us 0.1480 as the area of that shaded region, the area between these two z-values. So the next question asks us about finding some z-scores. Remember what the z-score is it's the number of standard deviations from the mean. The number of standard deviations from the mean. So if we know how far a particular value is from the mean, how do we do that? We take our value and subtract the mean. So that gives us the deviation from the mean, the distance from the mean. And then if we want to find out how many standard deviations that is, we divide it by the standard deviation. So that's how we'll get the z-value. If we're looking at the entire population and not just a sample, then x bar changes to mu and s to sigma. But in either case, we're dealing with means and standard deviations. X bar, remember, is just the mean of a sample, where mu is the mean of the population. S is the standard deviation for a sample. Sigma is the standard deviation for the population. So we're told that for a standardized exam, the mean scores have been 1501, and the standard deviation of the test scores been 311. So we're given a list of different test scores. 4 different students were selected at random, and here are their test scores. So they want to find out what is the z-score associated for each one of those. So let's find the z-score for 1910. If this was someone's score on this test, how many standard deviations is that? So we're just going to use the formula to find the corresponding z-value. So we need to find out how far is 1910 from the mean. So take 1910 and subtract the mean. That gives us the deviation, how far away it is. Then we want to convert that into how many standard deviations is that. So 1910 minus 1501. So this score is 409 units from the mean. Divide that by 311. So that's 1.3, let's go to 2 decimal places, 1.32 standard deviations away. So that's farther than 1 standard deviation, but it's not quite 2 standard deviations. So that tells us how far above the mean we are. So the next score was 1240. So let's find the z-value associated with 1240. So we need to find out how far from the mean. So 1240 minus the mean. divide that by 311. So 1240 minus 1501, that is 261 units below the mean, negative because this is less than average. And then we want to find out how many standard deviations is that? Well, 261, that's less than a full standard deviation. So notice when we divide this, 261 divided by 311, that's not quite a whole standard deviation from the mean, negative 0.84. So negative means that we're less than the mean. And the 0.84, that tells us how far away from the mean are we. So if the mean is 1501, 1240 is on this side, and if a standard deviation is that long, we're less than that distance from the mean. We're about 84% of a standard deviation to the left. And it asks you to do this for 2 more, but if you can do it once, you can do it 4 times. So next, let's answer this question. What is the probability that z is less than negative 1.39? The probability that z is less than negative 1.39. So let's draw that. So 0, remember 0 is the middle, the mean. And so negative numbers are this way. So here is exactly where a z of negative 1.39 occurs. We want to find out how much is less than that. If we're just throwing darts, what is the likelihood of being in this region? If we're randomly picking up a test value, what is the likelihood that it has a z value that is less than negative 1.39? So we just need to find that area. So we look at the table, we go to a z value of negative 1.39, which the 09 column is the first column. So negative 1.39 is here. So the area to the left of that is 0.0823. 0.0823. So if we need to know the probability that z is less than 1.39, that's just that corresponding area. And that's it.